Okay, so let's put some of these rules into practice. The first one, what we're going to do is we're going to do the log base 4 of 7 times 5. Now, of course, we could have written that, and it's not 7.5, that is 7 times 5. We could have written that as 35. Obviously, that's okay. But if I wanted to split it up, I could do 35 as 7 times 5. So what I can do now is, because I have two things being multiplied together in my argument, I can separate those through addition. Because remember, I've got two bases being multiplied together. That means we can add the exponents. So we're going to rewrite this as the log base 4 of 7 plus the log base 4 of 5. So we had two things being multiplied here. We can separate them into two separate logs through addition. Again, two logs, two exponents. That's all that means. All right, let's do one more. We'll do one with a variable in it this time. So we'll do the log of 10x. Notice I did not write a base. Hopefully you remember, if I don't write the base when I write the word log, the base is 10. So once again, I have two things being multiplied together. I've got 10 times x, which means I can separate this into two logs. I'm going to have the log of 10 plus, because it's multiplication over here, the log of x. And that's perfectly fine for separating them. This is what's called expanding, by the way. That's perfectly fine for separating these things. There's one other thing I can do, however. Because it is understood, and I'm only going to write it here, it's understood that that base is 10. I now have the same base as I do the argument. And if you remember from our previous sections, if I take the log of something where the base is the same as the argument, that log is 1. So I can simplify this one more step. This would be 1 plus the log of x, and that's the most simplified version of that when we expand it. Okay, let's do another example. This time we're going to use one of the other properties. We're going to do the quotient rule property on these. So let's do the log of 19 over x, and we'll say base 7. All right, now I've got two things in my argument which are being divided, which means I am allowed to separate these into two separate logs. And what you want to think of is, how many things within my argument do I have either being multiplied or divided together? That's going to tell you how many logs you have. In this case, I have two things, 19 and x. Those two things are being divided. So I'm going to separate this into the log of 19 base 7 minus, now because it's a division problem, log of x base 7. And the log of 19 base 7 cannot be simplified easily, so we're going to leave it just like that. Okay, let's do one more of the division problem. So we're going to take, this time we're going to use the natural log. Natural log of e cubed over 7. And remember, with a natural log problem, we do not write the base, but the base, and I will write it just this time, the base here is always e, although it's not usually written. All right, so when we separate this, again, I've got two things. I've got e cubed and I've got 7 being divided, so I'm going to separate those into subtraction. So it'll be the natural log of e cubed minus the natural log of 7. Now, this first one can actually be simplified. Okay, the natural log of e cubed, in this case I am actually going to put the e down here to make it a little bit easier. What you have to think of yourself is this. If I were to take this, I'm going to erase this in just a second, but if I were to take e and raise it to some power, it's got to give me e cubed. Well, the only power I can raise e to get e cubed is 3. So that means that this has to be 3. The natural log of e cubed is 3. When we actually get to the next property, when we do one, I'm going to show you an easier way to figure that one out. And then still minus natural log of 7. Okay, let's go ahead and do a couple of power rule problems, and hopefully the one that we just did will actually make a little more sense after that to you. or at least another way to think about it. Doesn't have to necessarily not make sense now, but there'd be another way to think about it. Okay, so we're going to have the log of 7 to the 4th power base 5. All right, so what you want to think to yourself is, well, wait a minute, I don't have, 7 is not being multiplied by anything, and the 7 is not being divided by anything. So I don't have pieces that way, but I do have the exponent on the 7, which is a 4. Remember, the idea was, since it's an exponent raised to an exponent, we can multiply the exponents together. The easiest way to think about it is just to know that if I have an exponent out here, I can bring it out to the front. So we're going to simplify that to be 4 times the log of 7 base 5. Okay, let's do another one. Let's say that we have the natural log of the square root of x. And you might look at that and say, okay, well, I don't have things being multiplied because it's just the square root of x. I don't have things being divided. It's just the square root of x. I don't see a power. But remember, you can rewrite a root as a power. So before we even deal with anything else, I'm going to rewrite that square root. And if you remember, the square root is the same as the 1/2 power. Now, hopefully, you can see what I have as an exponent on my argument. So I can bring that exponent out to the front and rewrite this as 1/2 the natural log of x. Just bring the 1/2 out to the front. The power goes to the front. Okay, one more example actually of this, and then I'm going to kind of take it back to part B. In number 2, I should say. So let's do the log of 4x all raised to the 5th power. We're actually combining a couple of different things here. All right, so when we do this, the first thing you should be able to see is I do have a power on my argument. I can bring the power out to the front. So I'm going to have 5 times the log of 4x. But then what you should see is I also have inside of the argument, I also have two things here being multiplied together, which means I can separate those into two separate logs which are being added together. The biggest thing is that 5 out in the front goes with both of them in this case because the 5 is being multiplied by that log. So when I rewrite this, I'm going to have the 5 log of 4 plus, because it's a multiplication on the inside, 5 log of x. Okay, and that 4x on the inside told me I was going to have two separate logs. The biggest thing was that 5 out in the front here, this was getting multiplied by the entire log, so it gets multiplied by both of the pieces. All right, now let's go back up here real quick and see that, okay, we probably could have made part B up here just a little bit easier. So I'm going to recopy what we had up there. So this is going to be from example 2, from number 2b here. If we were to take the natural log of e cubed and we wanted to simplify that, well, remember now we can actually bring that exponent out to the front. So that's the same thing as 3 times the natural log of e. And the natural log of e is one of those special circumstances where the base, again, we don't usually write it, but the base is e. So I have the base and the argument of the same thing. So that this whole piece right here, because the base and the argument are the same, is just 1. So really what I get is 3 times 1, or just 3. And that is exactly the same thing as what we had up there. Okay, as I mentioned before, one of the things that we're doing here is what's called expanding log expressions. That's what we were doing when we were separating those logs into multiple logs. It's called expanding a log expression. So we're going to go ahead and put that into a very small application here and show you what's actually happening. So when we expand a log, we're going to make it a little more complicated. We're going to add more pieces to it. So we're going to have the log base b of x squared times the square root of y. And all of that is part of the argument. Okay, so what you have to ask yourself is, first of all, if I want to expand this, how many different things are being multiplied together? Well, I can see I have x squared times the square root of y. Two things being multiplied together. This is going to separate into two separate logs. So it's going to be the log base b of x squared. And because those two things are being multiplied, this is going to become addition. So then it's the log base b of the square root of y. Okay, but this is not fully expanded yet, because when it's fully expanded, there will be no exponents on your arguments. They will just be single values of some kind. Well, I can clearly see here I have a 2 as an exponent. That I'm allowed to bring to the front. But remember that this square root symbol right here is also an exponent. It really means a 1/2 power, so really that's a y to the 1/2. I can also bring that to the front, and they only go in front of their respective logs when they're being separated like this. So what we should end up with here is 2 times the log of x base b plus, remember that square root is a 1/2, so 1/2 log of y base b, and that is completely expanded. Okay, the variables, the arguments are just single variables. Nothing else there. No powers, nothing else being multiplied or divided. Okay, let's do another one. So let's say that we have the log, and we'll go with a base of 6 of, let's make this the cube root of x divided by 36 y to the 4th. So again, what I want to do is I want to count up how many things are either being multiplied or divided together. Well, I've got a cube root of x up here, I've got a 36 here, and I've got a y to the 4th there. I've got 3 things. So when I separate this, when I expand this, I should have 3 different logs. All right, so I am going to start off by writing the log base 6 of the cube root of x. That's the first thing. Now, the 36 is on the bottom, so when I write this, it's going to be now subtracted. So it's the log base 6 of 36. And here's the other trick. Yes, the 36 and the y to the 4th are being multiplied together in the bottom, but they're both in the bottom, which means they are both being divided by the top one. Excuse me, the top one is being divided by the bottom one. So we're still going to subtract the second one. Anything in the bottom is going to get subtracted when we rewrite it as a log. So that'll be the log base 6 of y to the 4th. Okay, we haven't finished yet because I do see exponents. I see things that have exponents on them, so I'm going to have to bring those exponents out to the front. The first one is a cube root, which is really a 1/3 power. So when I bring the exponent out to the front, it's going to be 1/3 the log of 6, I'm sorry, the log of x base 6. The second one here, the second one doesn't have a power, but what it does is it has a way to simplify. I'm going to skip that one and come right back to it. The last one does have a power. The power there is clearly a 4. That can come out to the front of that log and make that the log of y base 6 with the 4 multiplied out front. Now the middle one you have to be careful, because this right here, this base, if I raise that base to a certain power, I will get 36. So if you think about it, 6 to what power gives me 36? Well, 6 squared is 36. So 6 to the second power is 36, meaning that whole log in the middle simplifies to 2. And this is completely expanded and simplified. Okay, that's what's called expanding logs. We're going to come back and we're going to do condensing logs. Basically, we're going to take this process and go backwards.